Hey guys, today we're going to start off with a topic called mathematical fallacies. Now, what is a mathematical fallacy? It's something, it's a proof that can be proved, but then it's actually wrong. So, suppose if I could say I could prove that 2 is equal to 1. Now, we all know that 2 isn't equal to 1, but then there's a way to prove it. And I'm going to show you how. So let's take two variables a and b, and let's say that a is equal to b. This is what we have to prove. And now we have a equal to b. Now, after we square, let us square both the sides. So that's going to be a square is equal to b square. But then we know that b square is actually a into b because a is equal to b. So we can write this again as a square is equal to a into b. Now let's subtract b square from both sides. And then you're gonna get a square minus b square is equal to ab minus b square. And now if you know the identity that a square minus b square is equal to a plus b into a minus b, we can use that. So a plus b into a minus b is equal to, let's take b common, b into bracket of a minus b. Now let's cut a minus b and a minus b. Then you're going to get a plus b is equal to b. And now we know that a is equal to b. So let's say that 2b is equal to b. And then let's cut off b, 2 is equal to 1. And that's the proof. Now obviously it's wrong because there's a mistake somewhere in this proof, and that is over here in this line. So what I'm doing here is I'm canceling out a minus b from both sides, right? But then we didn't think of the fact that a minus b will actually be 0 because a is equal to b, so a minus b has to be 0. Like that has to be 0. And then if you take this line and rewrite it, you'll get a plus b into 0 is equal to b into 0. Now what we actually did by cutting these two sides was shifting a minus b to the other side. And that's what we're going to do here. So let's say a plus b into 0, and let's shift this 0 here. So that'll be 0 divided by 0 is equal to b. Now I showed in the previous video that 0 by 0 is actually not defined, or it's infinity. So that's where the whole proof goes wrong in this line, because you can't divide 0 by 0, then it becomes incorrect and your whole equation goes undefined. So that's the reason that this statement is completely wrong. So that was one type of mathematical fallacy we looked at. Another one would be something that is called a howler. So these are called howlers. So howlers are basically completely bogus types of proofs. So let's take 16 by 64. Now what a howler would say is that you cut off 6 and 6, you get 1 by 4. And that's actually correct because 16 by 64 is actually 1 by 4. But then the method to do it is completely incorrect. And this is what is called a howler. It's a very small thing, but then it's good to know about. So other examples of these can be 19 by 95, cut off 9, you'll get 1 by 5. And we know that 19 by 95 is 1 by 5. And another example can be 26 by 65. Let's cut off 6 and 6, and you'll get 2 by 5. And we know that 26 by 65 is 2 by 5 because it's both divisible by 13, and you'll get 2 by 5. Okay, so that's another type of mathematical fallacy. Another example can be to prove that 5 is equal to 4. This is what we have to prove. Okay, let's start with minus 20 is equal to minus 20. This is absolutely true. And then let us write this as 25 minus 45 is equal to 16 minus 36. And then let's write this as 5 square minus 5 into 9 is equal to 4 square minus 4 into 9. And if you see, what we're doing here is we're trying to get an equation which will look like a plus b the whole square, somewhat like that. Okay, so let's keep going. Now we're gonna add 81 by 4 on both sides so that we can get a perfect square. So let's see, 5 square minus 5 into 9 plus 81 by 4 is equal to 4 square minus 4 into 9 plus 81 by 4. And now 5 square is a perfect square, 4 square is a perfect square, and 81 by 4 is perfect square, and over here as well. So let's write that in terms of a perfect square formula over here. So that's going to be 5 minus 9 by 2 the whole square, because you've got a minus 2ab over here, is going to be equal to 4 square. Oh, sorry. So it's going to be 4 minus 9 by 2 the whole square. And then now let's take square root on both sides. And then you're going to get 5 minus 9 by 2 is equal to 4 minus 9 by 2. And then just cut off 9 by 2, 9 by 2, and then you'll get 5 is equal to 4. Now the mistake here is in this line. So when you take a square root, you can actually have two answers. So if I say that x square is equal to 4, and then if I shift this to the other side, then it's going to be x is equal to root of 4, which can either be plus or minus 2, because minus 2 into minus 2 is equal to 4, and even plus 2 into plus 2 is equal to 4. So actually both these answers are correct over here, and that's what we should do here too. So this will actually be equal to 5 minus 9 by 2 is equal to plus or minus 4 minus 9 by 2, and that's where the whole thing goes wrong. And that's all I have about mathematical fallacies. If you want to know more, then you can just visit their Wikipedia page. I'll be linking it in the description. Thank you for watching.